Okay, so acids and bases in the body. So your body is constantly going through many metabolic processes. And during those processes, it's typically producing acids um, that go into the bloodstream, right? And an acid is anything that produces H plus ions, okay? So any chemical that releases H plus ions will go dissolve into the water and make it more acidic. So, for example, the stomach does that on purpose. It releases large amounts of hydrochloric acid. So H plus is in high concentrations within your stomach. And that's why uh, anything that gets into your stomach can be helped in digestion due to the very powerful acid that's sitting in the stomach. It also destroys bacteria that you may have ingested along with your meal. Okay, so the stomach is not only protective, but it also has an important role in digestion, partly because of its incredibly powerful acid that it contains. Okay, the opposite of acid are bases, and a chemical that decreases hydrogen ions in the body is called a base or an alkali, right? And what will neutralize H plus in the body? Well, anything that typically has an OH attached to it, which is a base. OH with H plus will just turn it into H2O, which is water. Okay? And this is really important because the body, like most things, wants to maintain this term called homeostasis, which is a term you're going to hear a lot about. The body doesn't like things changing very much. It wants to keep many different parameters in very tight control. And one of them is your acid-base balance. So it doesn't want your bloodstream to be too acidic, and it doesn't want your bloodstream to be too basic. Why is that? If your bloodstream becomes too acidic or too basic, enzymes don't work very well. Cells begin to become harmed. Cell membranes can break down. Electrolytes start to shift in abnormal ways because the H plus is an ion and so is the OH negative. Okay, so we're going to spend time talking about acids and bases a bit. And when we talk about acids and bases, we're really talking about a pH scale. And the pH scale is going to tell us how acidic is a certain fluid or how basic is a certain fluid. And the main fluid that we're talking about in the body is blood. And when your body becomes too acidic or too basic, you become ill. Okay? So we'll talk about this on the next slide a bit more. So all kinds of substances have a pH measurement. Okay? And so does blood. And really all a pH measurement is giving us is how acidic is the substance, meaning how much H plus ions are in the substance, or how much are the H plus ions lacking. So if we look at the scale here, acidic, as we go down the scale, you become more acidic as you go down from 7, right? And it's exponential, meaning it's by a factor of 10 every time you go from 7 to 6 to 5 to 4. It's a huge difference. And on the opposite, basic, again, it's exponential. You go down by a factor of 10 in terms of your H plus concentration. And so really what it's telling us is how much hydrogen ions is in the system. And when we look at something that's extremely acidic, that would actually burn our fingers if we were to put our fingers into the solution, look at hydrochloric acid, a pH of 1. That would burn the skin off of your digits, okay? And the opposite, a pH, say, of 14, has negligible H plus because it's been neutralized by some kind of base. And typically that's OH in the body, right? So an oxygen and a hydrogen molecule that has neutralized the H plus, because when they combine, it turns into H2O, and it eliminates the H plus. So if we look at the examples here, and we look at blood typically has a pH of 7.35 to 7.45. And you might wonder, well, why are you being so specific with the pH? Well, that's really where the body keeps it. And we call somebody who has a blood pH of less than 7.35 acidotic. And we call someone who has a pH above 7.45 alkalotic. Okay, so very, very tight parameters for pH in the body, because it makes us very ill when we become acidotic. And in general, the body is constantly producing acids, and then the body is constantly trying to neutralize those acids in different ways, and we'll talk about that. Okay, so all these metabolic processes are taking place and making acids as byproducts. The body doesn't like that, so it has ways of clearing out the acid to maintain a pH between 7.35 and 7.45. Okay, so let's look at one process in the body as an example of how the body can clear acid out of the bloodstream. So if we go to the far right of this reaction, we can see H plus and HCO3. Okay, so H plus is automatically going to make the blood acidic, right? It's going to drop that pH as it builds more and more, and it's typically from metabolic processes that are occurring in the body all the time. But the body says, I want to keep my pH between 7.35 and 7.45 at all costs. So I'm going to combine it with bicarbonate that I have in my bloodstream. Where's bicarbonate made? It's made in the kidney. Okay, so you always have circulating amounts of bicarbonate. So the bicarbonate combines with acid, H plus, and becomes H2CO3. That's just an intermediate molecule, because H2CO3 can easily just shift to the left and become H2O and CO2. And where does H2O and CO2 go? Well, H2O can go in the urine. It can partly be expired from the lungs. So during expiration or exhalation, you breathe out some water molecules as well. But you definitely breathe out CO2. Okay? So how can we shift H plus out of the body? By breathing faster, right? Because we're breathing out more CO2. And because this whole equation is in balance, if I lower my CO2 on the left side, it's going to make more of the H plus shift towards the left, because I've lowered the CO2. And that is going to lower the pH because I'm shifting the H plus to combine with HCO3 to make H2CO3, and finally CO2 that I can breathe out. Okay, so this is one of the mechanisms in the body to maintain acid balance, is by breathing. Okay, there's other examples of how the body maintains pH in very tight parameters. This is just one example. Okay, so when we're talking about acidosis and alkalosis, it's just telling us the concentration of hydrogen ion in the system. So the more acidotic we are, meaning the lower pH on the pH scale, it's indicating more and more H plus is in the bloodstream. So let me give you an example of how important pH is. If you have a pH of 7.35 to 7.45, which is totally normal, if you were to drop to 7 on the pH scale, you would become extremely ill. If you dropped to 6.9 or 6.8, you're now approaching incompatibility with life. Okay, so it doesn't take much on the pH scale to become extremely acidotic. Okay, the same on the other side. The less H plus you have, because it's been neutralized, typically from, say, HCO3 or OH, you become alkaline. You have less H plus in your bloodstream. So you have a higher pH. You're alkalotic. Okay? So again, it's much less common to become alkalotic because the body is always producing acids. So the main role of the body is to try and clear all these acids that are occurring from metabolic processes. So that's going to be by far the most important compared to alkalosis. We will talk about alkalosis a bit, but acidosis is far more important and definitely more of a killer if patients become acidotic. Okay, but just to know the concept, a pH of less than 7.35 is acidosis. pH of greater than 7.45, meaning less H plus, is alkalosis. Okay, and alkalosis really is just saying I have less H plus because it's been neutralized by some kind of a base like OH or carbonate, which is HCO3. Okay. Okay, so the main reason we're talking about pH is because many disease states can cause a drop in your pH. You can become acidotic, right? And when you become acidotic, you become extremely ill. And a lot of processes in your body just cannot function. Your enzymes don't work well. The metabolism that's occurring in all your cells start to become dysfunctional, and your organs, such as your heart, your brain, all these organs start to malfunction. Okay? And again, this is a much more common occurrence with diseases to become acidotic. So let me give you an example. You are hiking in the woods on a very hot day and you become extremely dehydrated because you forgot to bring some water. Okay, so what's going to happen in the body? Well, the body's still maintaining its metabolic processes, right? It has to. It's burning glucose to make energy. It's circulating the blood to all your cells. It's trying to clear the waste from all the cells in your body. And the cells are dumping the waste into the bloodstream so they can be cleared by the kidneys. Well, say you become so dehydrated that your blood pressure starts to drop and you can't send blood to the kidneys anymore. You can't perfuse the kidneys. Perfuse means blood flow to a certain area. So, well, your kidneys are responsible for clearing waste out of your body. And they're also responsible for clearing acid out of your body. So if your kidneys start to weaken and start to fail because they're not receiving any blood, you can become acidotic, right? Because your kidneys were unable to process the blood from lack of blood pressure that can deliver the blood to the kidneys, and now your blood is becoming acidotic. What can your body do about it? Well, your body, if you look at that above reaction we just spoke about, well, I have too much H plus in my bloodstream. I can shift it in a reaction that occurs in the bloodstream to H2O and CO2, and I can breathe out the CO2. And the faster somebody breathes, the faster you can breathe out CO2. And that's why someone who's acidotic is breathing very fast, because they're trying to blow off more and more CO2, okay? To try and maintain their pH between 7.35 and 7.45, despite having a disease state that's causing them to become acidotic, okay? So the body is shifting its breathing state, its respiratory rate, to blow off more CO2 to keep that pH normal. Alkalosis, again, a term for a pH greater than 7.45, and as I mentioned before, much less common than acidosis in the body. Okay, so let's use the bloodstream as an example of neutralizing acids. So we already mentioned that acids are byproducts of metabolism in the body, right? All your cells that are constantly undergoing all kinds of processes to produce energy, to maintain all the processes within the cells. As a byproduct, they produce H+. Where does H+ go? Into the bloodstream for the body to get rid of, whether it's out through the kidneys or converted to CO2 in that above equation and breathed out through the lungs. Okay, so if we have in this example HCl, hydrogen chloride, and NaOH, sodium hydroxide, when they react, the H plus and the OH is combined to make H2O, so the H plus is neutralized. Okay, so as long as H plus is neutralized in the bloodstream, it's often with bicarbonate, HCO3, which is made in the kidney. As long as it's neutralized, you can maintain your pH within normal levels. Okay, let's look at a place that's very acidic, the inside of your stomach, which often can have a pH of between 2 and 3, which is unbelievably acidic. Okay, a lot of H plus ions in the form of hydrogen chloride. Okay, what happens if we take an antacid? So antacids that you buy over the counter, liquid antacids, they have some kind of a base in them. So they're going to have either bicarbonate, which is HCO3, or an OH molecule. In this case, sodium hydroxide. If you were to buy Tums, well, Tums is just calcium carbonate. And when you have a base, such as a hydroxide or carbonate, that combines with the H+, it neutralizes the H+, and reduces the acid in the stomach. Okay, so how can we control, say, someone with heartburn where there's acid refluxing up into their esophagus? Or how can we minimize someone developing an ulcer in their stomach? We can neutralize the acid by adding a base. Okay, so a lot of antacids you're going to see that are over the counter, including Tums, are just a neutralizing agent to combine with the H+, and raise the pH of the stomach solution.